I wanted to just let you guys know how I'm doing on the Khan Academy. Um, I'm sorry, not the Khan Academy, the Google Classroom. So make sure to completely do the notes. So no, yesterday we didn't do the notes, but make sure you do all the screens. And when you do the notes, do them in full. I do check every single one, and if you just kind of have a little bit of notes, see what I have here in red. I I got to give you less points, but with the opportunity for you to go watch the video in full. Please don't take any shortcuts here. We're not going to do any like real testing in this class. So the best way to get your good grade is to do all the practice, um, and thereby gaining some knowledge, of course. So eventually, I might have some quiz or test, but it'll be open notes, open internet, open helping each other out. Um, so I can't wait to see how you guys work together with the assignment that I'll have for like a test or a quiz. Um, so please do your best on the notes. Don't skip. Don't just give me something simple. Um, I have really good examples of notes. Let me see who's here. Um, Sophia, is it okay if I show the class one of your notes?
Yes.
Sure, thank you. I really appreciate that because I want to give an example. You know what? Honestly, and if I was a student here, it'd be hard for me to make them this quality. But definitely, you want to have an idea of what good notes look like. Let me find one. I should have had this ready, by the way.
Yeah.
And again, nothing is late, so make sure to keep that in mind. You just don't want to wait till the last minute. Here we go. What is this? How is this thing sorted? Sophia, here we go. Here's an example. I don't know, just some random one. This is assignment 8. I remember this. This was a short one, actually. So as you can see, it's got really good notes in terms of the function. I think we were talking about a absolute value one, and then versus a parabola. So you can clearly see like understanding here. There's some good like bubbles of here, like some important things. Uh, so keep that in mind, guys, as you're doing the notes. All right. So for today, we are going to do something similar to yesterday since I thought it worked out pretty good. So can you guys all go ahead and open up the PACE? And I believe I open the PACE for you every day at 11. Go to the student Desmos and let's see if that works. Okay. And and we're just going to review yesterday so that we're just going to like touch base on the two forms that we know, and then I'm going to introduce a third form. Um, and remember, I'm talking about my favorite childhood show called Robotech, um, that had the pilot. Um, the airplane that was actually an alien airplane technology that the humans learned to use, and then but the aliens wanted to come back and get their technology, and it turned out that they weren't actually bad guys after all. They just wanted their ship back. Spoiler alert. Oops, spoiler alert, it's too late. All right, so is everybody on the new activity? And I'll go ahead and take a peek to see if you guys are on there. Let me just open up my teacher one. Um, so on this one, on the very first screen, and hopefully you guys are on there already. The first screen is I drew the function, And your job is to use the steps to reverse it. Normally, you get a function and then you graph it. Well, in math, everything works forward and backwards. And so then when I did it in reverse, so the reverse is I gave you the graph, and now you type in the function. All right, so go ahead and take a look. Only 5 of you guys are there, so let's wait for everybody to get in. Maybe that's all the people that are here. There's shows like 13 people here. All right, so go ahead and remember, go to the PACE and open up the link, the student one, right? Number 13 student, and use Google so I can have your name. And all right, so let's look at the first one. And I know we're waiting for everybody to kind of jump in here, but let's peek at number 1. All right, so Nathan, I opened up yours. What do you notice? What's kind of very visible here? What's the first thing that stands out from the function, from the graph?
I don't know, the steps are just the normal size, I guess.
It has the steps in normal size. Yep. All right. And Claudia, what else do you notice? The steps are normal, the 1, 3, 5, probably 5, right? If you got 1, then the next one's 3. Claudia, what's the other thing that you notice about this function?
What do you mean?
Let me give you thank you. I appreciate that. I'll give you a multiple choice. Do you notice the y-intercept, x-intercepts, or vertex?
Vertex.
Vertex. So if you know your vertex, and Nathan says you got the normal steps, then can you guys type the function? So would you type it in factored form, or would you type it in vertex form?
Vertex.
Vertex. So go ahead and everybody type out what you think it is, and then we'll talk about it and we'll discuss it. So if you know the vertex and the steps, then you got everything you need. It's almost like if you wanted to make a pepperoni pizza and you had pepperoni and you had the dough and the cheese and the oven and stuff, you could make a pepperoni pizza. All right, let me see how you guys are typing. Does it let you type the function nicely, or is it kind of funky? Let me see. There we go. It does have the, yeah. And go ahead and type in an explanation. I think it asks for like an explanation. How do you know? And you could say, oh, I know the vertex. All right. And I know the x of it is going to be the opposite, right? And then I know the steps. The steps are regular, okay? Good. Everybody's. Exponent. I do know how to type an exponent, but there you go. Nathan says put the caret, which is on top of Shift 6. So press Shift 6, and that'll do the caret. Okay. Good job. And Sophia, make sure to get that the exponent. Okay. The exponent, which is Shift 6, will give you the exponent to have the 2. And same thing with you, Van. Make sure to get that exponent. And I know you probably know that. I just probably forgot about it. Okay. Perfect. Okay. Good job. And Amar, go ahead and type in the function, like type in the actual function. Take a peek at my screen and you see everybody's typing in the function. Okay. Cool. There you go. Good job. Okay. Get it. Got the squares. Perfect. Nice. I know the vertex and the steps. So if you know the vertex and the steps, you can write it in vertex form. Okay. Nice. Good job. I'm really proud of you guys. Actually, this is really good. Like I started this about 3 weeks ago, and I've been thinking about it. By the way, I've taught this probably for the last 8, 9 years, but every year I change it up a little bit. I always try to figure out, well, how can my students learn better? Okay. So I feel sorry for my students that were with me 9 years ago. Okay. All right, let's all move to screen 2. Screen 2. And do the same thing. What do you notice? And then what do you notice about those steps? Are they the same? Are they different? and where would that extra number go? Okay, and if you're not sure, you can actually ask the class. Say, there we go. Amar, I think this actually, you could actually do it in factored form, So Amar, actually go for it. Go for it in factored form. So you could actually do it in either way. And if you know how to do it in either way, go ahead and write both forms on your answer. So I actually gave it so that you could see both. Okay. So you can say, wait a minute, this one is in vertex mode and in factored mode. Like, I could totally see both. Okay. So good job, Amar. I was actually not looking at that, but good job. And you guys do know that the steps are 2. So you're putting that 2 in the front, okay? Hannah, take a peek, all right? Take a peek at my screen and see what other people are thinking about that 2. Oh, there you go. I see you fixed that. Good job, okay? Good, good. And you're using the function notation, which is f of x equals, okay? And Amar, if you get into calculus, capital F is for a different kind of stuff. So when you do functions, you want to do lowercase, all right? And take a peek at my screen and see about that, the way you're typing it could be helpful to you to see how other people are working that out. Good, good. And then, there we go. And then Sophia has both the vertex form and she's working on the factored form, the same thing. It'll give you the same function, okay?
Mr. Canus?
Yeah.
It's not letting me do a lowercase f.
Oh, that's okay. Don't worry about it. It's okay. And one more thing, Claudia, what about that 2? Since the steps are double, there's got to be a 2 somewhere. Take a peek at my screen and see how other people are addressing that that the steps are double. The 2. The first one was 2. The next one was 6. The next one was 10. There we go. And on your vertex one, also slide in that 2 in front of the x plus 3. All right, and Hayden 2, make sure to type in that 2 since the steps are double, right? The steps are double, so you want to put in that 2 inside of that. Amar, I think the F is probably because on the next one, and don't worry about it this one, on the next one, type in that in the answer, and then when you explain, do the second part. And then for your, there we go, you're fixing that. It's not comma 2, it's plus. There we go. Good job. Great. Good work. And Hayden, take a look at your answer. Make sure to put that, since the steps are 2, you got to put the 2 in front of the parentheses, okay? Since the steps are double. Good, good. All right. Good, good. Hannah says I can use the vertex form or I can use the factored form. I get a choice this time, okay? This one is I can see my function in airplane mode, or I can see it in robot mode. I can see both of them, okay? I'm really curious if one of you will actually start watching this show. It's really, really good. I'll even tell you how many seasons there was while you guys doing that. Robotech season. That's how you know when shows are good. They have a lot of seasons. All right, so there is. Oh boy, season 3, oh my god, you can watch them somewhere. 1985. Wow, I thought it was 1990. Yeah, that's right. I was actually in middle school. Wow, very cool. 36 episodes on season. Wow, no wonder I was hooked. All right, let's all move on to the next screen. And don't forget, ask me questions. All right, this one, same idea. Unfortunately, I couldn't get the steps to show properly, but they're going down. And you kind of could see the x-intercepts. I zoomed in a little. What size is the first step? How How big? Yep. Good job. And Nathan, are the steps going up or down?
Down. I just fixed that.
There we go. So that's going to cut all the steps in half, all the previous steps. Now I should have made this so that you could see the steps clearer because they're by twos, so they're. So in quadratics, do you need to see all the steps or just the first step? What do you guys think? The first step is going to give you the a value, that number. All right, and good job. You guys could put it in decimal, like Nathan. You could put it in fraction form, like Shiv. Okay, there we go. And this one, I guess, you can do it in both formats. Okay, very good. You can even put 0.05. Good job. Good job. And Hannah, don't forget to put the square, which is the caret. Which is shift 6, and that'll bring you to the exponent. To put that 2 in the exponent. All right. Very good. Good job. Okay. And Devin, the same thing. When you get a chance, put that square. Okay. There you go. Good job. And then Van 2. Remember, the shift is the square is going to be shift, and then 6 is going to give you the exponent ability. Okay. Right on. Perfect. You guys are becoming masters at this. By the way, I finished my son's book. It's really good. I gave him some feedback. My wife finished it, and then he sent me a new version to start reading some of the questions he had. Really, really good book. Can't wait till it publishes, and he really will see for sure. Other people will see for sure his talents of writing. All right, so let's see what you guys are up to. Good job. Good job. Very good. Okay, let's go on to the fourth screen. And it looks like I got a little bored of making. Oh yeah, so this one I made it a little different. I want to see what you guys do with this one. I want to see what you do in the factored form. I'm really curious to see what you guys type. All right, you can see the steps, right? Normal steps. I want to see what you do on the factored form. That's what I'm curious about. Good. Good, good. Very good, Nathan. That's pretty much what it looks like. I wanted to see what you guys would do with the factored form. Go ahead and don't forget to put the exponent on your vertex. And if you want, Nathan, on yours, on the factored form, you can get rid of the parentheses in front of the first x. There we go. Okay. And if you want, go ahead and do a new one and distribute the x to the x and the -4. Make a third function. So distribute the x inside. Now you have three functions. And so that, let's see, there we go. There we go. And then if you get stuck, look at my screen. You can see how the people are working that. All right, Nathan. And now you've uncovered the third form. the third one, what do you notice about the third function that is exactly the same output as the middle function and exactly the same as the first one? What do you notice about the third one, Nathan?
There's a lot of X there, I guess.
Yeah, there is. Yep, exactly. There is. It's not going to be X. It's not going to be like enclosed in a parentheses, right? There's no. Is there any parentheses on the third one?
No.
Nope. There we go. No parentheses. Everything is distributed. Okay. So take a peek at my screen, guys, and you can see some of your peers' work. Okay. And you can see the third function. So I was really sneaky of introducing the third function to you guys. So take a look at Nathan's. Ship's got the third one. And now you know what the third function is. The third form, right? And that one is called standard form. And let me just kind of go back to my amazing show, plugging it in. Okay. It's so good. Start of season 1, episode 1. Now you know what the third form looks like. And the third form is, using my analogy with Robotech, would be your half robot, half airplane mode. I think this one's a good one right here. Here we go. See, we got the airplane. By the way, later on they brought in bikes. It's kind of like Transformers type, but different. So here is the third one's kind of a mixture. So there's the airplane, the robot, and then the half and half. So the third form is called standard form, and we're not taking notes on it right now. You're just hearing me. And all right. So the third form, there is no parentheses. Everything is distributed. Okay. Very good. All right. Let's go to the fifth screen. Okay. Fifth screen. All right, write the function for the parabola below. Oh yeah, so this one I made the steps really small, really tiny. So how do you make 1 become smaller? There you go. And then you could do it as a decimal, or you could do it as okay. And then go ahead and do the factored form. And if you want to try to put it in standard form, give it a try. But this was going to be a little bit harder to do in standard form. Actually, you could do it. Actually, you could totally do it, but it's tricky. All right, so it's a quarter. So they went up by a quarter. Good job. X minus 2, x minus 4. Okay. Remember, if you're stuck, I got all of your guys' peers' work showing here. Good work. Got to have that quarter, right? The quarter is gonna cut those. And you can try it with a fraction, like 1/4. It's the same thing. Okay. Anybody want to try to convert it to standard mode where there's no parentheses? What do you think you'd have to do to convert it to standard mode? Let's see. Let me look at Sophia's. Sophia, you'd have to distribute the quarter into the x and into the -6. Let me see if I can use you'd have to distribute the quarter in here, and then you'd have to distribute the new thing into the x and into the 2 and the -2 and then the negative. So it is going to take some work. Okay. And it's not going to be easy like the last one, because the last one there was only basically 1 parentheses and 1 x. This one you have to distribute a lot more things. Let me see if I can have a little tool here. You'd have to. And can you guys look at my screen real quick? Let me. Whoops! I accidentally paused it. Dang it! Oh well. Oops. Shucks. Seems like I learn something new every day. I close a certain screen and then it paused the recording. Darn it. If you're watching this recording, sorry about that, guys. I'll go back a little bit. So we're actually on screen 8, even though it says number 6. I got to fix that. And you are saying, oh, this is easy. I know this is in robot mode. I mean factored mode. So that's going to be x is 4 and negative 2. Then you're going to see that the axis of symmetry, which is in the middle of those two numbers. Okay, here's Sophia's here. And then Sophia, go ahead and plug in the data on your table. And what I like to do, I like to go from 4 and I go down all the way to negative 1, kind of like this. So I go from one x-intercept to the other, and then boom. And then I said, oh, the output is going to be 0. So I want to see you guys have the table filled in. And you're like, okay. So then the vertex is going to be smack in the middle right there. Make sure to get that. So then I'm just going to plug in 2 into the function, and that's going to be 4 times, that'll be negative 8. And then you can do up 1. Up. Wait a minute. Hold on a second. 1 second here. Is the vertex at 2 or is it between 1 and 2?
It's actually at 1.
It's actually at 1. Let's see. Did I miss something? 4, 3, 2. Oh, I missed 0. See that? There we go. I missed in my table. I missed 0. There we go. Thank you. So you plug in 1 into the function, which is 1 plus 2 is 3. So that'll be negative 9. And then I went up 1. Then I went up 3. That'll be negative 5. Then it. Does that make sense? Okay. All right. There we go. Thank you. Good job, Sophia. Okay. All right. So it looks like most of you are almost done with the graphing. Good job. Okay. And Hayden, when you do a graph like this is really good. You want to just maybe do, no, that's good enough. Yeah. Just, if you could do one more, so that would be up 10, 1, 3, 5, 7, right? So you could do one more, but this is fine. But you could actually go up one more to 7, right? And then you can stretch your graph a little higher. Okay, this is good though. Okay. Good job. All right. I think I had gone to, I wanted to stop at 10. We're almost done. Good job, Amar. Very nice. Okay. All right, guys. So here is, go ahead and let's move on to screen 9. Even if you didn't finish, that's okay. Okay, because now it's just a process. So here is my intro to standard form. And question, is there any parentheses?
No.
Nope, no parentheses. Now, typically, you're not going to put x times x, you're going to put x squared. But in the heading, I can't actually do exponents when I do this thing. So it doesn't let me do exponents, so I just put x times x. So your job, and I'll do it with you, is to try to get some inputs and outputs, okay? And would you like me to tell you where the vertex is? I think some of you maybe did it on Desmos. What is the vertex? And I'll tell you what it is, so you don't have to like guess. And why do I want the vertex? Why would I want to do the vertex for this function? Like, why do I want to start at the vertex? Anybody have an idea? And go ahead and type in, and go ahead and look at my screen right now. And I'm going to tell you that the x of the vertex is -1. That's the vertex. And so then I could go 4 up. Or let's go 3 up. And then 3 down. There we go. So the x of the vertex is -1. What would I do with -1? What would I do with an input? I think I've asked that question like almost every day. What do you do with inputs? Anybody? Okay, fine. You input them. Inputs are made to be inputted. So you're going to do -1 times -1 plus 2 times -1 minus 3. So what is -1 times -1? +1. 2 minus 2 times -1 is -2 minus 3. So this is 1 minus 5. This is -4. That's my vertex. -1, -4. Okay, so go ahead and put that point at Oh, you can't quite see
I
it.
have a question.
Yeah.
So, where'd you get -1 from?
Oh, so very good question. Like I would, if we were in class, I would be like, yeah, 500 points. So I cheated. I typed this equation in Desmos, right? Like, and later on, I'm going to show you how not to do this. Watch. Just take a look at my screen. So I went to Desmos, and I went x squared, right? Plus 2x minus 3. And I said, oh, it's negative what?
1.
-1. Now later on, I'm going to give you one formula that you can use that's always going to let you figure that out without having to cheat like I did, right? So now I showed you how to find the y, right? Now, if you were in Desmos, you could have said, oh, it's -4. Like I see both of them, right? I see the x and the y. Like, why do the math, right? But I proved it. It's -4. Okay. All right, next question. What would you like to plug in? Would you like to plug in 0, or would you like to plug in -2 into the function?
-2.
Yeah, which one is less work?
0.
And yeah, 0 is actually less work. Because if you plug in 0 to all of the x's, and I'm going to use red. What's 0 times 0?
0.
0. What's
It's going to be -3.
Exactly. So this is going to be negative what? 3 right here. And by the way, how much did it move up from -4 to -3? Did it move up the normal pattern, or did it move up a different amount? Did it move up? Did it go by 1, or did it go by 2? Did it go by 3? What did it go by? From -4. And by the way, this I didn't give you the right graph to graph this, so I don't even know how to change this. Let's pretend that these numbers are by 2. Okay, so your first point is going to be at -1, -4, right there, and the next point is 0, -3. So it's right here. So how much did it go up? What was the rise of the first step? How much did it go up by? So how much did it go up from -4 to -3? I'm looking for you to say 1. So therefore, the next one's going to go up by 3, and the next one's going to go up by 5, and the next one's going to go up by 7. And look how fast I graphed this. And this is going to be the mirrors of it, okay? And let's not graph it because the graphing is going to be too hard to graph. So go ahead and just fill in the table. So fill in the table like I did. How much math did I do? A lot or a little? Look at my work on my screen. How much math did I do? All right. Not a lot, right?
Very little.
Very little. I just plugged in the -1, basically, right? And then when you had picked to plug in 0, you see that all of the x's disappear and the 2 disappears because it gets multiplied by 0. And then I said, wait a minute, my pattern is 1, 3, 5, 7, and it did go by 1. So therefore, the next one must be 3, and the next one must be 5, the next one must be 7. Okay? So today, I'm just introducing to you standard form. Okay, we're not going to do a lot of this. I'm just going to introduce to you. Okay, so make sure you have the table, and then this will be our last screen right here. Okay. All right. So let's cheat a little. Let's type this into Desmos, and I'm going to tell you what the vertex is. 2x squared, and then what was the other thing? I already forgot. Minus x minus 4. Okay, minus x. Now, all I care about is what is the x of the intercept of the equation. And this one is actually a decimal. It's a quarter. Okay. Now, if you typed it into a calculator and changed all the x's into a quarter, it would give you -4 and 12 cents. So I'm gonna just so then I'm gonna say my vertex is a quarter. So this is really hard because the vertex is not in our normal spot. So it'd be 0.25. So this would be 1.25. This would be 2.25, 3.25. Whoops. This is 4.25. Now, so as you can see, standard form is more complicated than the other two. You guys agree with that?
Yeah.
Yep.
Yeah.
But there's only one good thing I like about standard form. And guess what it is? And Amar kind of hit on that. What is the easiest thing to find just by looking at it? And I'm actually have my screen waiting for you to answer that. And then the multiple choice would be x-intercepts, y-intercepts, or vertex. Which is the easiest thing to, just by looking at it, what would you know is there?
So I don't really understand the question.
Yeah, so you know how in vertex form, you could totally just see the vertex just by looking at it?
Oh yeah.
And in factored form, you can see the x-intercepts?
Yes.
All right, so each one's good for one thing. What is standard form good for? Just by looking at it. Is it vertex? Like, no, right? I can't see the vertex, right? Is it x-intercepts? No, I can't see where the x-intercepts are just by looking at the equation. So what can you see? And I'll have the graph over here. And I'll even point to everything.
The y-intercept.
The y-intercept, look at this. What number is that? -4. And if you look at my function, it's right here. -4. So even though it's not like very helpful, well, it gives you that at least, okay? And by the way, Nathan, how come all the x's disappeared and the 2?
Because x was 0.
X is 0. And if you're going to multiply anything by 0, they disappear, right? So, and this is where we're going to stop for today. For the standard form, the only good thing is the y-intercept. And everything else is going to take work, okay? So later on, when you have a function in standard form, you're going to want to convert it to factored form or convert it to vertex form. See my little screen right here? And then, so basically, I'm going to call the half robot, half airplane standard mode. When you have it like this, you're like, oh, this is kind of funky, right? I want to convert it to factored mode, so I know my x-intercepts, or I want to convert it to vertex mode, and that'll give me the vertex. Okay, so that's where we're going to continue tomorrow, just for a little bit. We'll take our time, though. Okay, so great job, everybody. Okay, I think the last screen I had that I wanted you to type something in was, and I'm going to force you all to go to it. Hang on. All right, I'm going to change the question here, okay? And the question is, write down everything you learned today, and even if it was a review of yesterday. And this is where I'm going to be grading screen 4, okay? So write down everything that you learned or reviewed from today's lesson. You could even say, I learned the vertex mode, and I learned what standard form looks like. I learned that the y-intercept is easy to find on standard form. I learned that the steps help you with the number that goes outside, right? And I'll change the question, right? How do you graph functions that are in vertex? Yeah, I need to change this question right here. And how, I'll even write the question here somewhere. How, I'm not sure where I can write it, actually. Here, I'll type it here. What have you learned today or gotten better at doing today regarding quadratics? I'll give you some options. Vertex, form, steps, y-intercept, factored, mode, and then also tell me which is your favorite type of mode. Like, which one do you like the most? Do you like the factored one? Do you like the vertex one, or do you like the sucky one, standard one? It's factored mode, standard mode. Actually, it's called form, not mode. Vertex, y-intercept, x-intercepts, upside down, bigger. How do you know steps are bigger? Bigger steps, smaller steps. Okay, let me copy this before I lose it. Okay. And then you can share that with the class, please, so that people can see. Now, let me see what you guys are typing. Good job. Okay. Good, Hannah. Yeah, standard mode. All right. Good. Okay. Good.
Mr. Quinones,
Yep.
I need to go to another class.
Yeah, of course, and I definitely respect that. So thank you for signing off. And you don't have to post anything today, so I'll get your guys' scores from here. Okay.
All right. Thank you so much. Bye.
Bye. Thank you. Good job. Okay. And if you don't mind, when you sign off, just say bye, and that'd be appreciated. That's your signing off. Good job. Thank you. Good job, Owen. I see that. Bye.
I have to go to another class, Mr. Quinones. Have a good day.
You too, man. Take care.
Okay.
All right, Mr. Quinones, I'm gonna sign off.
Yeah, right on, man. Okay, tomorrow I'll try to have it done by 11:45. So 45 minutes we'll have our time.
All right, for sure.
Yeah.
See you.
Thank you.
So for whatever reason, it's not letting me go back and finish my previous questions.
Oh, yeah. I'm sorry. Here, that's my bad.
Okay.
Let me stop that. There we go. Go ahead now.
Okay, cool.
Thank you.